For this video, we're going to start Chapter 5, Lesson 1. Now, you'll notice hopefully that my microphone's a little louder. I did turn it up. The heater turned on about 10 minutes ago, so it's extremely loud. So I don't want that to interfere with you being able to hear the video. In Chapter 5.1, we're going to switch from going into proportions and fractions and ratios and unit rates into percentages. Now, when we look at percentages, we have a lot of things that we have to talk about. First, we have to understand what the definition is. And our definition is, once again, highlighted in yellow with our vocabulary word. It is a ratio or a rate that compares a number to 100%, which means per hundred. The symbol for percent is the two circles with the diagonal slash. So it's a ratio or a rate, but our comparison is 100. So we're going to do a quick review because we've been talking about putting things over 1, and now we're going to be putting things over 100. So when we look at what we talked about before with ratios and rates, we've talked about with ratios how we have certain amounts to a certain amount, comparing boys to girls, or in this case, dollars per hour, or in this case, miles per gallon. Could be red to blue, depending on whatever the items are. And in unit rates, we've talked about how they had to be put over 1. So in this situation, in both of these post-it notes that are being worked out then, I see that my ratio that's originally given is 630 to 40, and on this one it's 150 to 4.2. So when we've talked about ratio and rates, we've also talked about how we can have an uncommon denominator when we compare things, and we have to figure out how to solve for those. We've talked about how we can have an improper fraction. Both of these are improper, but we also talked about how we could have one of ours having a decimal point in it. So in that ratio, we have a decimal point. In unit rates then, on these, they've reduced both of them down to where the denominator is 1. So the 630 to 40 does reduce into a unit rate of $15.75, there's that decimal again, per 1 hour. And in this ratio, the 150 miles per 4.2 gallons, it reduces down to a unit rate of 35.7 miles per 1 gallon. So when I talk about percentages then, I'm talking about taking whatever the percentage is and putting it over 100. All I do is I keep the numbers themselves. So I have 46, and I put it over 100. I have the 7 from the 7%. I put it over 100. 130 over 100. That's my improper fraction. 0.2 or 0.2% over 100. There's my decimal. Now, why in the world do we have to do that? Well, we're going to get into going over Chapter 5, doing math with percents. And we talk about all sorts of percents from this point forward throughout the year, and you'll also be tested on when it comes to the I-step. So it's important to understand that I can't use a percent in a math problem. Now, if they tell me in the math problems that I get into a little later on in the chapter that I have to use the fraction form, I have to use the fraction form. If it tells me I have to use the decimal form, I have to use the decimal form. But the nice thing about most percent problems is they don't tell me which one I have to use. And there are some of you that are really strong and you really prefer fractions. And there are some of you that are really strong with it and you prefer decimals. So the percent problems, you can do either way as long as you know what it means. So the whole basis of understanding today's lesson, 5.1, is truly understanding what a percent is and how I use it as a number first. Because as a percent, I can't use it. So they introduce us back to things that we haven't used in a long time since we were little kids. If you remember those base 10 blocks, most of them are blue, and you get one little cube for 1, and then you get a stack of 10, and then the big solid square was 100, and it's 10 across and 10 down. Well, they're going to look at that because, once again, our denominators have to be 100. So the first example we look at, it says to shade the grid to show 35%. And if it's out of 100, then I know I'm talking about 35 of those blocks need to be shaded in. So when I say that I'm talking about 35 out of 100, I shade in 35 of those blocks. Go ahead and do that on your paper. Now the thing about shading in the blocks is most of the time I just go from left to right, and when I look at my 10s and my 3 column, I fill in 3 straight ones, and then my 5s I usually start from top to bottom. It really doesn't matter. I think that's probably the quickest way. We're starting at the top and filling in 3 straight across, and then halfway or 5 of the 4th one. But you can do all sorts of shapes and things, but if you're wanting to do it quickly, just fill it in the easiest way for you and make sure that 35 are truly filled in. So once I have it filled in, it says to think, well, that's 35 out of 100 squares is what then when it comes to a fraction? So comparing shaded in to how many blocks there are, that's a ratio or that's a fraction of 35 over 100. So when I talk about my fraction of my percent of 35, then I know that I'm talking about 35 100ths. So when it goes back to the question of what I was talking about, then it says, so by 2025, which is a few years from now, we have 35 out of 100 cars may be powered by electricity. Question 5 then says, to model 52% on a 10 by 10 grid. Now you could, if you want to, and that's up to you, go back onto the box that you have and just highlight the 52 for the 52%. I understand that you would be covering up the 35. You could work backwards and do 52, 1, 2, 3, 4, 5, and then 2 of those in the 6th row, and then there would be a few white ones left. You could draw the box if you want to. I don't care, as long as when it says to shade in, that you actually shade in. So on B then, it says once you've shaded it in, that I have 52 out of 100 squares is 52 out of 100. So 52% equals 52 to 100 as a ratio, and I color in my 52. You can shade it in any way you want as long as 52 of them are indeed shaded in. So then I just copy and pasted another one. Once again, you can choose a different color and see what you get. But it says to model 18% on the 10 by 10 grid. So we're talking about 18 out of the 100, or the fraction of 1800ths. So then I shade in 18 of them, and I know that that is going to be 18 over 100. Now none of those did I reduce, but we'll talk about that here in just a moment as I continue forward in this lesson. Now, I said please notice this because I want you to notice how this chart is set up, because not all of the charts they give us beyond this lesson are going to be as easy. When I look at what we're talking about Meigs meteorites, and that's the paragraph that I covered up with my image here. We talk about what the things are made out of, and we have iron being 21, and stone being 76, and stony iron B3, and notice what I get when I add those together. When I take the 21, 76, and 3 and add them together, I get a 100. So they make this pretty easy here at this first lesson, because it's all going to be out of 100 that I'm comparing. They could have made it more difficult and given me numbers that totaled 50, and then when I talked about my percents, I'd have to double all those. We're going to get to that here in a few lessons. But when I first start out, I'm going to look at the information from my graphic source. Once again, charts, pictures, anything that gives me information as a graphic source. This is my graphic source in order to solve this problem. It says, if I'm talking about iron from this chart, what am I talking about? I'm talking about 21 out of 100. So I fill it in as 21 out of 100, and then I shade in the chart for 21 blocks. Don't care how you shade it in as long as you do it, and there are 21 that are correctly shaded in. Then when I talk about my percentage, well then I'm talking about 21 out of 100, which then, instead of going from my percent and putting it as my numerator, I take my numerator and I write it as a percent. For stone then, I look at my graphic source, and Stone tells me it's 76. So I know I'm talking about 76 out of 100, because my denominator is 100. So I write 76 out of 100 on my lines. Then I shade in 76 of them. So my fraction, once again, is going to be the 76 out of 100. And once again, notice, I'm simply going to take my numerator from the fraction that I created and add my percent sign. And then I'm left with stony iron. And stony iron, they tell me, is 3. So I know I'm going to have 3 out of 100, where I shade in only 3. And then I write that as my fraction of 3 over 100. And once again, I'm going to take my numerator and just add a percent sign. So it's always my numerator that becomes my percent. If I have my fraction or my percent, then I know that just simply becomes my numerator with a denominator of 100. So as I work through these then, this is a really short lesson and it shouldn't take you very long to do. So I'm going to ask you to make sure that you're following along and filling out your book. And if you have questions, I'm going to ask to see your book to make sure you're following along with my video. It says on the practice problems then, write a ratio and a percent to represent the shaded part. So they've already shaded it for you, and you have to figure out what that's telling you when it comes to the ratio, once again, out of 100, and the percent. Once again, we won't talk about reducing them until our next lesson. So when I look at them, I have complete rows of 10, 10, 20, 30, 40, 50, and then 1, 2, 3. So when I look at it, I know I have 53 out of 100. And when I take that numerator and I add a percent sign, then I simply have 53%. When I do the next one, well, they're trying to trick me, aren't they? Because that's a complete box. So when I talk about a complete box, I'm going to have 100 out of 100. Does that change what I'm going to do? It doesn't change what I'm going to do at all, because I will keep my numerator and I'm going to write it down, and that's going to be my percent. Now the label of percent is already there, so you don't have to write the percent sign. Please feel free to do so. So 100 out of 100 is indeed 100%. Now, look at what that tells me. When I'm talking about percents, I'm always talking about out of one whole, unless I go over 100%. But if I talk about one whole, like that box, then I'm always talking about 100%. So if you get a pizza and you divide it into 100 teeny tiny squares or pie pieces, and you eat all of them, you're still eating 100% of the pizza. What's the chance of rain today? Well, the chance could be there's 100% chance of rain. We're all in. We're going to get wet. So when I look at this one then, on number 3, I count how many columns of 10 I have filled in. I don't have any spare ones anywhere. So I have 10, 20, 30, 40. So I know my ratio is going to be written as 40 out of the 100. I keep that numerator, and I add my percent sign. So I know 40 out of 100 is 40%. We're almost done. So once again, I hope you're focusing, following along, filling out your book so you know what we're doing. Now it says to model the percent and write it as a ratio. So modeling means I'm going to fill in these boxes. Yes, you have to fill in the boxes because you're asked to. That's the directions. And on your homework, you will be expected to fill in the boxes as well. That's called showing your work, and that's one of your extra points. So when I have 30%, I know I have 3 groups of 10. So I have to fill in 3 groups of 10. And then when I write it as a ratio, I know I'm going to take my percent, I'm going to put it over, so my percent is 30, I'm going to put it over the 100. So I know that 30% is the same thing as 30 100ths. This one gives me 5%. So once again, I don't care how you fill it in. Fill it in as creative as you want if you have the extra time and you want to do so. But don't get lost in making pretty designs and then not getting all of your homework done. So I filled in 5 different ones. I take my percent, I put it as my numerator. My denominator is the 100. So I know I'm going to have a ratio of 5 to 100. And then my last one they give me is 75%. So I have to fill in 7 groups of 10 and 5 single ones. You design it however you want. I got a little creative just to show you that I don't care how you do it, as long as you do correctly and you get all of your work done. It's not about making pretty shapes. It's about understanding that we're talking about 75 pieces out of 100. So I take my percent, I put it as my numerator. My denominator is out of 100. So I have 75 100ths, or the ratio of 75 to 100. So the whole idea is understanding what we're talking about. So when it asks me to explain, and please understand, in chapter 5 we start doing more of these in our homework assignments. To explain, I have to use words then, what I'm doing, so that the grader of it, right now on your assignments, that's me. When it comes to iStep, that's anybody that's been hired to read them, that they understand that you truly have the concept of what is being asked. Explain how to model 32% on a 10 by 10 grid. How does the model represent the ratio of 32 of 100, or to 100? So first, I would color in 32 boxes on the grid. With 32 boxes colored in, then 68 would be left white, and that would give me 32 colored and 100 total boxes. So by doing that, I can explain word by word what it is that I'm doing in order to understand what is being asked. Take a moment, if you want, pause the video so you can get all of that written down. I will check if you come and ask me questions, and then I'm going to move on to question 8. Final one, a floor has 100 tiles, kind of like Mrs. Ross's floor in her classroom, all with the different squares on the floor. There are 24 black tiles and 35 brown tiles. The rest of the tiles are white. What percent of the tiles are white? So I kind of changed it into a multi-step math problem that looks a little different than what we have been doing, because I wanted to show you this process. I see a lot of you, when you know that there's a couple ways to subtract, that you're trying to subtract like 3 numbers stacked together. That is mathematically impossible. But I can do it this way. Okay? I could stack it, which I'll show you, and I'll write it out here in just a second. But if I know I'm starting with 100, and I know then that 24 of them are black, I could subtract that and get 76, and then I could build directly from that answer and make that part of my next subtraction problem. So then when I have 76, I know 35 of them are brown, and I could subtract and get 41. So I know that there are 41 white tiles. What that would look like if I stack it, what I was talking about is I have some of you doing this. Oop, not 41. It's supposed to be 35. And then you're getting really confused as to what to do. It's because mathematically that won't work. But if I want to just stack it, I could do the first subtraction. I could do my borrowing through. That would give me my 76. And then I could do my next subtraction with it by taking my 35 from it. And I'm still going to get that there are 41 white tiles. So if there are 41 white tiles, then the final portion is, well, what is my answer? My answer is 41%. So as we go through this lesson and getting into all of chapter 5.1, it's so important that we understand what we're talking about. We're talking about something out of 100 pieces. Okay? It could be a group of 100, or it could be something that's been divided into 100 pieces, like the grid that they give us that's 10 by 10. But understand also that I can't use those percents in a math problem. I'm going to have to write them as fractions, or I'm going to have to write them as decimals. So when we talk about ratios, we're comparing one number to another. And when we're talking about unit rates, we're talking about one number or one set of things compared to another number, but that number has to be unit rates of 1. Percents is not 1. Percents are out of 100. That's the most important part about percentages. Because if you come and ask me questions about what this means or how to set it up as a math problem, I will ask you. A percent is always out of how many? Know that it's out of 100, and then we'll work from there. Go back and rewatch the video if you didn't understand or if you have questions about it. If you need to slow it down and make your notes, then that's fine. Look at my board for your assignment. Come back to me if you have any questions.